Hello 3D printing friends. Today on the BV 3D channel, we'll learn how to install heat set inserts in your 3D prints. I'm Brian, and you are watching BV 3D. Hi, welcome back. Okay, so today let's learn how to install heat set inserts in your 3D prints. So what are they anyway, and what are they used for? Heat set inserts are these little brass things with a knurled outside and a threaded inside, and they're used for making strong threaded holes in your prints that you can screw other things onto. So think about a case for an electronics project where you need to be able to screw the case parts together. Heat set inserts are available in a variety of sizes with different outside diameters, inside diameters, and depths. And they're not just found in 3D prints. You'll see these all the time in consumer products with injection molded parts. In fact, here are some in an Ender 3v2's fan shroud cover. Heat set inserts are actually melted into place, so they become one with your print. Typically, this is done with a small soldering iron, but you can't just take a printed part and melt a heat set insert into some random location. Okay, strictly speaking, you can, but that's not how it's supposed to be done. The result won't be pretty, and it probably won't be very strong. Models have to be designed with heat set inserts in mind, so they've got holes in the right places. Holes that are just the right size, so that when the insert is melted into place, it's not displacing too much plastic. The holes also have to be designed with the right depth, so there's enough room not only for the insert, but for the screw that's supposed to go in there when the model is assembled. If you're planning on using inserts in a model that's designed for them, make sure you order the right kind. The designer has probably specified the inner diameter, outer diameter, and length of the inserts. In many cases, the designer will have a link to the specific inserts they've designed the holes to fit. I designed and printed some test parts to demonstrate how to install the inserts. To keep things short, I'm not going to cover the design process in this video, but I am going to show you how to install them. But if you want me to make a video about designing for heat set inserts, leave a comment and let me know. If it looks like there's enough interest, I'll make a video for you. Alright, so let's talk about installing these little things. I mentioned that one way to install these is with a small soldering iron. And you can do that without any special tips or anything, as long as there's enough room for the iron's tip to go down into the model. You do have to be careful because the soldering iron's tip usually protrudes through the insert. But depending on the insert, the iron's tip may need more clearance than the model offers. So from Amazon, I bought a small, cheap soldering iron and a set of tips that are specifically designed for installing these inserts. The soldering iron is a mostly okay one for about 20 bucks. It's got a small knob that you can use to set the temperature, and it has a little LCD screen to show you what the temperature is set to. Unfortunately, the temperature display is faint, and it's also in Fahrenheit, both of which start with the letter F, and neither of which is particularly useful. To make the heat set tip fit tightly, I also needed an ever so slightly shorter outer sleeve for the soldering iron, so the grand total for the iron and the sleeve and the tips was about 42 bucks. There's links in the description to this stuff if you want to take a look at it. To install the tip, unscrew and remove the outer sleeve. Then remove the soldering tip, put in the heat set insert tip, and put the sleeve back on. The insert tip kit has 5 tips for different sizes of inserts. I've screwed on the tip for M3 inserts. You can see the tip is stepped. The diameter is smaller at the end, and then there's a larger stepped part right after that. This design allows better heat transfer to the insert, and it helps to keep the insert in line with the soldering iron. So the way this will work is you'll heat the iron up to about the same as the printing temperature of the material that you're inserting these into. Now, by the way, you might want to do this on a heat-resistant surface like a silicone mat. That way you won't accidentally burn your work surface. The one I'm using is Wham Bam Slap Mat. These are thicker than regular silicone mats, and they're available in a variety of sizes, even coaster-sized, and they're perfect for something like this. So, while the iron is heating up, place the heat set inserts in the holes if you can. How easily you can do this probably depends on the type of insert, but the ones I'm using have a slightly smaller diameter on one side, and that will just fit in the hole. That keeps the insert in the ready-to-be-inserted position, which is kind of handy. Once the iron is up to temperature, line up the tip, insert it into the insert, and keeping the iron as vertical as you can, press straight down to insert the insert. You should insert the insert until it's just below the surface of the part you're inserting the insert into. Then lift the iron straight up and out, and you can move on to the next one. Keeping the iron vertical is important. If you're off by a little bit, the insert won't be straight up and down, which means that any screw that screws into it will have to match the insert's angle to align with the threads. A slightly fancier and slightly more expensive way to do it is to buy a dedicated heat set insert machine like this one. While not strictly necessary, it does ensure that you've got the iron very vertical. Plus, it's kind of cool looking. It includes the soldering iron and the heat set insert tips, plus you're getting a metal base plate, a 2020 aluminum extrusion, a 2040 aluminum extrusion, a depth stop, and a spring return mechanism. Also, the temperature display on the included iron is easier to read and it displays the temperature in Celsius. Like the separate parts I mentioned earlier, there's a link in the description if you want to check this out. This one was $60 when I bought it, and the next day it was $50, and now it's out of stock. I'll link to it in the description anyway, and link to a couple of other ones that are in stock. Like the first one, to use it, heat the iron up to about the same as the nozzle temperature that you used when printing the model. Then pull the arm down to insert the insert. That spring-loaded return is handy because it keeps the iron raised above your workpiece. After you've got the inserts inserted, you can assemble your model. Now, this is just a simple demo model, but I'll screw the top part into the bottom part. The inserts are actually pretty strong, and you can tighten the screws down fairly tightly because the inserts have those knurled edges and they get melted into the plastic. Now, don't go too crazy tightening the screws, but you can crank down on them more than you could if you were just screwing the screws directly into the plastic. There. The demo model is assembled. It may not be much to look at, but you can see that the parts are 100% perfectly aligned. I've got these models linked in the description if you want to hone your heat set insert skills. So that's how easy it is to use heat set inserts in 3D printed models. Big thanks to everyone who supports the channel, whether through channel memberships or using the links in the description. If you liked this episode, give it a thumbs up and maybe consider subscribing so you don't miss future episodes. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go put heat set inserts into something cool.